Hi, and welcome to the third of 3 videos for section 10.5. As you can see, I left a couple pieces from the last example we did up on the board. It'll make more sense here in a minute why. I promise I wasn't lazy. The eraser didn't get full of ink for a specific reason. So solving matrix equations. So let me box this off for a minute. Let's say I want to solve x minus 2y minus 4z is equal to 7. 2x minus 3y minus 6z is equal to 5. And negative 3x plus 6y plus 15z is equal to 0. If I look at this example, I can rewrite this as what? I can rewrite it as a matrix with the coefficients. So 1, negative 2, negative 4, 2, negative 3, negative 6, negative 3, 6, 15. So if we were solving this by reduced row echelon form, I would also put these guys along the far right here, get that, and it would tell me what the answers are. But I can rewrite this system as the matrices of the coefficients, my x, my y, and my z is equal to whatever the constant should be, 7, 5, and 0. Because remember, matrix multiplication says what? If I do the row times the column, I get what? 1x minus 2y minus 4z equals 7. X minus 2y minus 4z is 7. 2x minus 3y minus 6z is 5. Same as the second. It will work the same as the third. So if I want to call this, let's say, matrix A, and if this is matrix B, and I'm just going to call this capital X, it's my unknown, the variables. That means what? That means I have A times X is equal to B. So matrix A times matrix X equals matrix B. Using the inverse matrix, if I multiply on the left here by the inverse matrix, and on the left over here by the inverse matrix, and now the order is important because A and B aren't the inverses of each other, so I have to make sure that if I'm multiplying on the left here, I multiply on the left there. Well, this one I know the order doesn't matter. It's the identity matrix, right? So really on this left side, I just end up with x is equal to whatever the inverse matrix of A is times my B matrix, the constants. So if that's the case, if I have to solve this system and I'm told what the inverse matrix is, because why did I leave this? This A is what? 1, negative 2, 4, 2, negative 3, negative 6, negative 3, 6, 15. This matrix in the last video that we found the inverse for, this is the same as a matrix of the system of the coefficients of this system. It's the matrix of the coefficients of this system. So that means if I want to know what's my x, what's my y, what's my z, I simply need to take the inverse of this matrix and multiply it times b. Well, I figured out the inverse matrix. So it's negative 3, 2, 0, negative 4, 1, negative 2/3, 1, 0, 1/3. If I multiply this by b, which is 7, 5, 0, this will give me my values for x and y and z. So let's do that. We have what? Negative 3 times 7, negative 21. 2 times 5 is 10. 0 times 0, 0. Negative 4 times 7, negative 28. 1 times 5 is 5. Negative 2/3 times 0 is 0. And then last, 1 times 7 is 7. 0 times 5 is 0. 1/3 times 0 is 0. So my x, my y, and my z are equal to negative 21 plus 10 is negative 11. Negative 28 plus 5, negative 23. 7 plus zeros is 7. So that is my solution to that system. So if you were given an exam problem and it said, solve this system given that A inverse is this, well, if you recognize that the matrix A is this, well, if it says the A inverse of this matrix is that, then if you recognize that, oh, this system, the coefficients create this exact same matrix, so I don't have to do reduced row echelon form. I don't have to find the matrix C. I don't have to do any of that long stuff. I'm already given what I need, which is just the inverse matrix times the constants gives me what my answer is. So kind of a cool little shortcut there, solving these systems of matrices if you're given the inverse matrix of the matrix of the coefficients. So that's it. That's 10.5. Come on back. We'll look at 10.6.